Good afternoon, everyone, and welcome to the second edition of the Vitodens 200 Commissioning and Startup Series. This is the end of the current group of training. We've done introduction for 100 and 200. We've done application and installation for the 100 and 200 E-Series Vitodens. And today was the second half of, or second portion of the Vitodens 200 Commissioning Startup. We will be running some additional training probably in September-ish. We haven't set a schedule for this yet, on cascading and common venting and those type of things. So look forward to those coming up. But today we're going to do the Vitodens 200 Startup Commissioning. With me today is my usual wingman from the left coast of Canada and British Columbia, Scott Bootlier. Good morning, or good morning. Is it still morning where you are? It must be still morning where you are.
Still morning where I am.
Still morning where you are.
Yeah, out here in left field, I guess, Mark, is where I am.
Left field, on the left coast. Yeah, the left coast here.
Yeah,
I never quite understood that, because I think if Canadians are always looking south to where it's warm, it should be the right coast, but I guess it's north is left of north. So,
well, they used to call it the wet coast, but we haven't had rain here for a while, so it's we'll stick with the left coast, I guess, is more appropriate.
Yeah, and I guess it's morning in Alaska too, because somebody just said good morning from Alaska. So there you go.
Hey, good morning up there in Alaska. Yeah, nice
Alaska,
to have you.
Where maybe it's still cold. I don't know. It's probably not cold, but it's probably colder than here.
Probably lots of daylight though.
Yeah, lots of daylight. Yeah. I'm going
to
let Scott handle. Well, you're going to handle all the questions, because I'm going to talk and you're going to write. You're going to type. How's that? Always 70. It's 70 degrees in the southeast of Alaska. That's
sweet.
Not bad. Yeah, that's pretty close to what it is here.
That's almost banana belt right there.
That's right.
Yeah.
So I'm going to let Scott talk about questions, and then we'll get through. The products we're going to talk about today is the Vitodens 200 series of the 200 boiler of the E-Series boiler. So these two boilers here are the next generation of Vitodens 200 and 100. And we talked a lot in the commissioning and startup about how we spent a lot of time in developing this based on a lot of contractors' input and engineers' input. So these two boilers are on the current version of the CE series controllers. The Vitodens 222F and the Vitocross 300 CU3A will remain on the existing control for the time being. They will also be updated in the future. Same with the larger size, larger than 199,000 BTUs. Vitodens 200 will stay in the existing controls. They are part of the commercial boiler platform, so they end up having to do a few more things in the background. So that project is a separate project. So the Vitodens 200 is what we're going to talk about today, and we're going to start with what do you need to do to get the boiler ready to go here. So you've installed it. You've taken into account what Scott talked about piping and layouts and regulators and all that kind of stuff in the last few weeks, and now you're ready to start the boiler up. So the first thing you're going to have to do, obviously, is turn it on. So the power switch is relocated on this new series. It's on the bottom front right-hand side of the boiler. It used to always be on the front panel or behind a sliding door on the front panel. Now we've moved it to the bottom, and it's just an on-off toggle switch to turn it on. If this is the first time you've booted up the boiler, you will get the language screen. And that will, you have a choice of American English, which is North American English, and Spanish and French Canadian French. Those are the three languages that are on our North American boiler. So we've eliminated a lot of those languages that the Europeans use that were more confusing than anything else, especially if somebody changed it on you. So the three languages are going to get on the very first screen if you've never started the boiler before. If it's already been commissioned, you're going to get the home screen or the base screen that whatever was assigned during commissioning. You have a choice of what's going to be that home screen. So you'll get that. If you want to go back to the commissioning stages, that is possible. You'll have to go into the service menu and go back to recommissioning the boiler. We'll talk a little bit about that as we go through here. So you'll be able to tell if somebody's already been playing with the boiler before you got there, depending on what screen it shows up on. The first thing we want to make sure is the system is full of water. So we have a couple of helps and features in the boiler to do that. We want to make sure the expansion tank is properly pressurized. This expansion tanks are typically coming from your wholesaler at 12 psi pressure charge. That's based on typically a 15 psi system, because your expansion tank is ideally on the low pressure side of the system, meaning it's on the suction side of your pumps. And then your pumps produce a little bit of head to get over top of the building. It'll be a few pounds less than your design system pressure. If you have a system that's 20 psi, you're going to have to put more air or more nitrogen into that tank before you get going. So this is a good idea to do that, to say, well, I'm going to need 20 psi in this system. We need to pressurize a tank to say 18 pounds right from the very beginning, before you connect it to the system. If you're dealing with an existing system that's already full of water, you're just swapping out a boiler, then you want to do that pressure check with the system cold. You don't want to have any heat on it, because the expansion in the system will give you an artificial back pressure on that. So first thing you want to do is check the expansion tank. Just as a general housekeeping rule, you're going to have the gas valve shut off. That just prevents any kind of a flow switch banging on and off. If there's a call for heat already, the burner trying to start and stop, it'll fail out and it'll just sit there and wait for you. There are a couple of ways we get around that later when we're starting the functionality of the filling and purging. We supplied 2 sediment taps, or 2 drain taps with the boiler. The first one you see here with when we're marking B, or sorry, A is wait a minute, there we go. B is the fill valve. It's on the return side of the boiler. We fill from the return. And then we have another valve on the outlet we call the drain valve, and marked as C on this drawing. And we're going to use those 2 connections to help flush and fill the system. So those, you're going to want to hook up a hose to both of those, and have somewhere where the drain valve goes to a bucket or to a floor drain or something like that for this function. You're going to shut off the heating system valves once the system is full. This is, again, assuming you have a full system already. If you haven't got a full system already, we can use this whole process to fill the system. You're going to open up the valve and you're going to fill the system, and you're going to flush through the boiler. So we're going to open up the C valve here and open up the B valve. We're going to push water into here, circulate water through the heat exchanger, make sure all the air is out of it, and then down to drain. This will make sure that the boiler loop itself upstream of the shut-off valve. So right here and here, hopefully you've put isolation valves in, or the existing isolation valves that separated the boiler from the building. Then you're going to activate the filling function. You don't want to activate the filling function until you have some water in the system. If you do that ahead of time, your pump runs a dry pump, and that's not good for these wet rotor cooled pumps. So we want to make sure that we have the system full. When you start the filling function, it's tagged as filling on the system. Your pump will run for 20 minutes. The diverter valve will be moved to the center position. So if you're not using any domestic hot water, you're going to cap these 2 lines inside here on an H series boiler. You're going to then run that pump for 20 minutes, and with the diverter valve in the center, it circulates the water throughout the entire boiler loop and the domestic loop if you have it, to push air through the system, to fill the system full of water. You may be adding more water as you go along here till you get the system up and going. You want to make sure that the system is pressurized to a minimum of 12 psi. The reason why we picked 12 psi, and there's no pressure switch here that says the boiler can't run below 12 psi. What we want to do with 12 psi is that in the worst case scenario where the boiler is running at its maximum operating set point of 180 Fahrenheit, and you have a low pump speed, so low velocity, you had it set at its minimum, say 50% of pump speed, you could potentially have enough heat from these efficient heat exchangers to boil water in the heat exchanger. So if you keep the pressure above 12 psi, then we're not going to get a boiling condition during the lowest flow at the highest temperature application. So this kind of just protects the system. On the European boilers, there actually is a limit for that, but we have it different in Canada because of the requirements of North American regulations. Once you've got that circulated, then you're going to open the valves and you're going to let the water circulate through the building. And again, you continue to fill the system and add more water as required to keep it at that 12 psi. The next function we have is purge, and purge is a little different than fill. What purge does is function the pump a little differently. So again, we're going to shut off the gas valve, good housekeeping, open up any air vents. So any air vent you have in the building, you want to make sure little caps are loose on them and you have open atmosphere to the vents on the air vents. And then you're going to start the purge program. And the purge program's difference between it and the fill is that it turns the pump on and off every 30 seconds. So 30 seconds on, 30 seconds off, 30 seconds on, 30 seconds off, and it will do that for 20 minutes. Both of the fill and the purge, you can reactivate again if you need longer than that, or you can turn it off if you're partway through and you figure that, hey, you've got it all out. So they can both be started and stopped manually. Again, the diverter valve will go into the alternate between heating and domestic, so it will purge the air out of both loops. And during both the purge and the fill programs, the burner will not be allowed to start. Again, so we've taken all the air out of the system. We had our expansion tank properly pressurized. We've added water through the fast fill on the boiler or through the feeder valve, however you wanted to do it. And we're going to then check the pressure gauge to make sure we have that minimum of 12 PSI. We're going to disconnect the drain and the fill hose. We're going to open up the gas shutoff valve now because the system's full of water, and we can get on with the rest of the commissioning. One of the things we want to do is make sure our condensate trap is full. We can purge that or fill that condensate trap through the vent connector like you see in the drawing here. You'll see they've got a bucket of water and just pour it in here. It only needs about 10 ounces of water. The water then will run through the heat exchanger like the condensate does and end up in the trap. This is a great concept, except that by the time you got there to commission the boiler, hopefully the venting is complete. So there's already a vent pipe on here. And maybe the guy who hooked it up, who did the plumbing and did the venting and the electrical, he didn't fill the trap. So one of the tricks that one of the contractors that comes through training in Waterloo periodically gave me was that he takes a little rubber cap off of here that we use for a combustion analyzer in, and he squirts water in there with like a sports ball or something. He can squirt water into the hole, and it percolates its way down into the trap, and then it's purged, or it's full. The reason why we want to make sure we do this up front is that the boiler will not have any water in it when it starts in the condensate. So you're going to have flue gas coming out the drain. So we want to put a trap in there and make sure that doesn't happen. And it may, not fill for a while, depending on how hard you're running the boiler or what the temperature is. If it runs above the dew point, then it certainly isn't going to fill that trap very efficiently. So we want to make sure you do that. Not only does it prevent flue gas condensate from ending up in the boiler room, but it also doesn't affect the way the burner is going to operate, because one of the things we have in this boiler is the mass flow air sensor on the burner, and it will change the fan speed if it doesn't see the pressure it expects to see through the heat or the airflow through the heat exchanger. So these are things that we want to make sure the trap being filled prevents that issue from happening as well. In this control circuit board where you hooked up the power, there's a little red dip switch right beside the 91 plug. In the Vitodens 200 single boiler installations, that should be in the off position. It's used when we cascade boilers together. It's the end of line termination for boilers to boiler communication. So it's switched on for both ends of the network. But during a single boiler installation, unless you're hooking this up to a gateway by itself, you won't need to have the switch on. So just as a single boiler installation, we're going to say that 99% of the time that should be off. Now, it should have been shipped in the off position, but we want to make sure you verify it, because somebody might have bumped it when they were wiring it or something like that. So just verify that that switch is in the off position. So now we're ready to commission the boiler. When we look at the menu structure of the control, we can see there's several places to go here, and we'll just do a quick walkthrough from what's going on here. So the dashboards on the left are home screens. So those are the screens that give you an overview of what's going on in the boiler, and you can pick which one of those is the default home screen, but they're all available through the moving the screen through the arrows. So you have the device status. And this is the screen that I would probably normally leave a boiler on. It gives me the information on what's going on in the boiler about water temperatures and set points and things like that from a quick picture. The DHW is specific for DHW, like the DHW set point, DHW tank temperature. Then the heating will be the whatever heating circuit or zone circuit you decided would be the main for that group. And you can, it will scroll through. So if the boiler, if it's sitting in this as a home screen and it goes to a domestic hot water call, this screen here will come up so that you can visually see what it's doing. But these are the dashboards. But what we're going to need to do for commissioning is we're going to have to go over here to the main menu. The main menu is the little picture at the top left-hand side of the screen, on the home screen, you'll see a red or orange button with 3 lines on it. That's the main menu button. And once you're inside that, you'll have a choice of a bunch of different things. Switching things on and off manually, so you can turn the heating circuits or zone circuits manually off. So you can say, well, I don't need zone circuit 1 to be active, or I don't need heating circuit 1 to be active. You can turn them on and off, same with DHW, or the entire system. You can basically shut the entire system down. Under the DHW group, we have the schedules for DHW, and we have set points and things like that. Under heating, we have the 4 heating circuits and the 4 zone circuits. We'll talk a little bit about the differences between those 2 things as we go through. Set points, time of day schedules for heating circuits. Zone circuits don't have schedules because they're designed to be used with a thermostat, and a thermostat then will have a schedule inside it if you want to schedule. So again, we have a set point or the outdoor reset information. Under information is just read-only information on various parts of the boiler. So this is, you go through there, or the homeowner can even go through here and say, okay, well, look, it's this zone's at this temperature, that zone's at that temperature. It's calling for domestic, the burner's on or off, just how many hours are on it, how many BTUs we've used, this kind of thing. Under settings is where we set up the basic information like language, time and date, whether we hear the beeps from when we push the button, the names, you can customize names of heating circuits, Fahrenheit or Celsius. These are all things that we can go back to. We're going to do some of this stuff when we do commissioning, but it's always good. You can always go back to these without requiring a password. When you get down in here, change password. If you do that one, I don't recommend you change the password, because if you change the password, we have to get in through the back door to fix that for you. It's not the easiest thing for us to do for you. Actually, it's a little easier now than it used to be, as long as the boiler is on the web, but it's still more of a pain than it's worth. So if you decide to change the password, it asks you what the password is first. So it's not like anybody can do that without knowing the password. And over here under holiday program, we have holiday program, which is a schedule for when I'm away. So if I'm going to be away, I'm personally going on vacation for a few weeks in August. And if I could set my boiler into setback and have it be in setback 24 hours a day. Holiday at home, we want to talk about things that are invented because of other things. I think holiday at home was an invention of our engineers because of COVID-19. Basically, all these guys were working at home. All the engineers were working at home during the lockdown. So they had to put their heating systems in the daytime operation when they would normally have been at work. So holiday at home allows you to take a date from one date to another date and say, don't go into setback, stay in daytime. So it allows us to do that holiday at home, or working from home, if you want to call it that. And then the message list will give you a bunch of different groups in the message list.
I wonder why they wouldn't have put isolate at home.
Well, probably because they figured about longevity. They were hoping that COVID didn't last forever. I would have done it like this too, right?
Yeah, absolutely.
Lockdown, a button called lockdown.
It's a whole different context.
Yeah, we don't want to do that anymore. So when you commission the boiler, you can have a commissioning 2 different ways. You can commission it through HMI, which is a human machine interface. That's the buttons on the screen. Or you can commission it through the app. What you need to commission through the app is the Vitoguide mobile app, which can be downloaded from your Play Store for Apple or Android phones. And you're going to need some information from the boiler to get this going. So there is a Wi-Fi sticker in the control. It's on the back of the display unit, but there are extra ones, and we'll talk about that in a second, where you can move them. But you're going to use either the app or the HMI. If you're going to use the app, when you get to that selection on the screen, it will say, hey, you need to use the app, right? If you say you need to have the app. So the Wi-Fi sticker looks like this, and there's under this little clip, this is the back of the display unit. there'll be a group with about 3 or 4 stickers on it. There'll already be one. This is one that somebody stuck to the back of the control, but there's already one also stuck to the back of the display unit itself as a permanent sticker, which tells you what's going on with that. Now, if you have to replace the display unit, it'll have a new Wi-Fi sticker that comes with it, because the Wi-Fi module is actually in the display unit. So what you're looking for is some information on the QR code. If you're going to commission with the app, then basically the app already has the QR code reader function in it. And if you looked at a couple slides back, it says continue with QR code. It will open up your camera, and you just point it at this QR code and take a picture of it, and it will give you a screen that looks like this one here with the boiler serial number that you can verify that you're talking to the right boiler. Not every phone works as good as some phones like this. There are, literally dozens and dozens of versions of Android from different manufacturers of phones. So if you're having trouble getting the QR code to read properly, you can use the other information. Now, on the sticker, you'll see there's a Wi-Fi symbol. There are more than one QR code on this boiler. There's a QR code on the rating plate, which is if you scanned it, it would take you to a website. They gave you access to manuals and things like that. But here you're looking for the Wi-Fi sticker. So this is the one with the Wi-Fi symbol. Now, if you're going to do it manually, there's 2 things you need. One is the SSID, which is the network name for the hotspot in the boiler, and the security protection password. So in this case here, in this boiler here, the SSID or gateway name is Viessmann 2214, and the password is 000422214. WPA2 is a security protocol that computer systems use. It's the same security protocol you have on your laptop or your desktop. It's the highest level of encryption available for these type of applications for Wi-Fi transceivers. So this is the password, and this is the SSID is the network for the hotspot. You don't need to have Wi-Fi access to commission this boiler with the app. What'll happen is, as soon as your phone gets this information, it will ask the boiler to talk to it, and the boiler will say, okay, you can be my hotspot buddy, and you'll talk to it directly. So the screen that you're going to see to make that choice is the programming unit or the software tool. If you pick the programming unit, you'll get a bunch of questions and answers that you're going to have to answer as you go through. If you pick the software tool, it's going to prompt you to install Vitoguide if you don't already have it on. So basic settings and advanced settings are 2 different main groups. We talked about some of these already. The basic settings: language, time and date, the venting and filling format, whether you want metric or imperial, data for your screen, what fuel you're going to have. You're going to pick a fuel, altitude. We're going to come back to this a little bit because this is an important aspect to make the boiler the most flexible that it can be. Contractor details. This is where you put your information in so that the homeowner can find you. If something goes wrong, they get a fault code or a message on the screen, they can push the contractor information. If you put your address and phone and your name and stuff in there, they'll get that. Whether the boiler is weather compensated or not, and I'm going to come back to that a little bit as we go too. Advanced settings for heating circuits or zone circuits. You're going to say, I have a heating circuit, I have this, and I use a domestic. These are the questions you're going to get for those type of things. What you're going to do with the extra input, the 96 plug, which we can program as one of these 3 options. What do you have for expansion modules? What do you have for Vitotrolls and maintenance information? So let's take a look at it from the beginning again. Pick the language. So you already saw the language screen at the very beginning when you booted the boiler. In commissioning, it's going to ask you again, because it might be a recommission. You might have gone back into the commissioning and it will start through this process again. So it's going to ask you for the language every time you go through the commissioning. Time and date, you have a choice of the format, whether it's date, month, year, or month, date, year, those kind of things. You also have a choice whether it's 12 or 24-hour display. If you're like me and I live with a nurse, my wife is a nurse, and we live in the 24-hour clock at home. So where our boiler would be set in the 24-hour clock. So she would be able to be easier for her to think it through. Me, I have to convert in my head because I'm a 12-hour kind of guy. I can only think in 12-hour packages. So metric imperial gives you Fahrenheit and Celsius and meters and feet. And again, this is part of the, if you need the meters in feet, is important because we're doing altitude settings, right? And whether you have daylight savings time or not, you can decide whether you boiler your particular zone has that. If you're from Saskatchewan, Canada, they don't do daylight savings time. And I asked the guys in my classroom one time, why do you guys not do daylight savings time? Why everybody else in the country does daylight savings time? Why are you guys different? And the answer I got was the cows can't figure it out. They want to be milked at the same time every day. So I know that there's lots of debate in different states and provinces in North America whether we're going to continue with daylight savings time. Some people want to be daylight savings time all the time. Some want it to be standard time all the time. Hopefully everybody gets on the same page so we're not, jumbling all over the place. But this is where you would say I want it or don't want it. And then later in the programming, you can decide when you want it to switch, because the Europeans switch at a different time than the North Americans do. This next setting here for single family or multiple family, this is important to the way the boiler deals with the heat load. If it's a single boiler application or single family application rather, you can assume that it's one family with one lifestyle and they live a certain way, and the boiler can anticipate those loads pretty efficiently with some history. If it's a multiple family like a triplex, where you've got 3 different apartments in the same house, and the schedules are they're how they use water and how they use heat are different. This allows the boiler in the background, the algorithms that they're using will better predict those multiple load ideas. So this is where you want to pick one or the other. If you didn't set this, in the reality, you may not notice any operational differences, but there might be some efficiency differences in the long term. Now, this is for common vented, and we're not going to see common venting on a single boiler application, obviously, but because this control can do multiple boiler installations, you have a choice of a shared connection or a single boiler vent. The shared connection would be common vented multiple boilers. This boiler series can do up to 4 Vitodens 200 boilers in a common vented system. So this is where I would pick that. There are some extra functionalities in the boiler when it's common vented for how the boiler works against the chimney. So you want to pick one or the other. And again, you're going to be able to go back to the filling and venting system from here. You'll see you can bypass it if you've already done that and you think it's okay. And I'm going to show you different screens. Like through the last page, we showed you the HMI. This one, I'm showing you the app. It's just showing that you can do it in both applications. The information is the same in both. It's just laid out a little differently, but I want to show you how you use. You can do it from either or. Then you get a choice of fuel. So natural gas or propane. And this is the neat thing about this boiler. If you had the older Vitodens 100 boiler, you had to put an orifice kit in. On the older Vitodens 200 boiler, you had to turn the set key on the valve. There, you don't have to do any of that anymore. The only setting you have for fuel conversion is this. You just set it to be gas or you set it to be LPG, and the boiler does everything else in the background. There's no burner set up. There's nothing you have to do to this boiler. You could literally switch back and forth on the fly in a hurry if you wanted to. You could, say, hey, man, we run out of natural gas because the main broke. Let's hook up a propane bottle to here. As long as we got the regulated pressure set right, we can go into the boiler, say LPG, and it would run on LPG without any other interaction from us. Once you've done a conversion, though, it's important that the next guy coming into the boiler room knows that you've done this conversion. So in the installation literature set, you're going to have these 2 labels, field conversion label and gas type label. The CSA rating plate is already on the boiler. So you're going to put these 2 stickers, which say it's on LPG, and there'll be a label that it's been converted from natural gas. So these 2 labels are important that you put on the boiler. Then we get to the altitude setting. The reason why the altitude setting is important for this boiler is because this boiler has what we call a mass airflow sensor on the inlet of the combustion air fan. What it's doing is it's looking for the right volume of air for that modulation position. And the boiler has the ability to speed the fan up or slow the fan down if there's vent length issues for long vent lengths, if there's wind issues on the vent from storm or prevailing winds. It also needs to know where you are so that it has the full functionality of that, because air mass is different at sea level than it is at 10,000 feet. So we're going to tell this boiler, hopefully within 100-foot increments, where we are in altitude. Now, this is not, you don't have to have it right down to the foot, right down to the meter. But you're going to, I played with this a little bit when we were talking about this a couple of months ago. And I just Googled my house. And in Google, it told me what the altitude was at my address, and it's probably, not my address, and the guy down the street that's 40 feet lower than me, he's probably got the same altitude on his address, but that's as close as we need to have it. As long as we're in, 100 or 200 feet or so, we want to be that close. And the reason why we want to be that close, because then it knows that it expects a certain air density at that altitude. So it can use the fan capacity, the speed up and slow down of the fan, to control the entire range of the modulation of the fan to compensate for long vent lengths or for wind shear. If you didn't set this, if you set it at 0 feet altitude and you were at 700 meters in this application, it would think the air should be a certain density, and it isn't. So that it won't have as much play on adjusting for things like the vent length and the wind pressure. So it's important that we set this up front. It's going to ask you if everything's connected. Did you wire it right? Did you fill it? Is everything ready to go? And then it's going to start asking you about how the controls are supposed to be running. So you have a choice in this boiler of weather compensated or fixed set point or constant set point. What this is do I need to see an outdoor air sensor? In the original versions of the 200s, you didn't have a choice of hooking up the outdoor air sensor. You had to hook up something to it. If you didn't hook up something to it, you got a fault. So guys that were trying to do a fixed set point on a zone circuit, they would still have to have an outdoor sensor. And a lot of times they just hooked up a sensor or resistor and threw it in the cabin of the boiler, and it read the boiler air temperature in the combustion box, right? And that was fine because it gave them a number that the boiler didn't care about. You don't have to do that anymore. If you're not using outdoor reset, just say no. You don't have to wire anything to the outdoor sensor terminal now. So that's what you're picking here. Whether you need an outdoor sensor for any of your loops you're gonna individually tell each loop what you want it to be, but this is globally on the boiler. Should it see an outdoor sensor or not? When we do outdoor reset and it needs an outdoor air sensor, it also needs to have a heating curve. And the heating curves are an ability for the boiler to look at outdoor temperature and change the boiler water temperature or the loop water temperature based on that outdoor temperature. If you think about heat loss, heat moves from a warm place to a cold place faster with a greater temperature difference. So my building loses heat faster on a -4 Fahrenheit day than it does on a +68 Fahrenheit day. So because of that, we have to, we can tell the boiler we have outdoor reset, and it will match the heat into the heat loss when I set the heating curve appropriately. So we're going to give you a short little video here on what to do that. But you have two different ways to do heating curves. The first one is with a heating circuit. So we have heating circuits and we have heating zones, or what we used to call zone circuits in the Vitodens 200. And in a heating circuit, it's traditional Viessmann HC1, HC2, HC3. Now we have 4. And it has this room adjustment parameter, because we can also put a room sensing device we call a Vitotrol in the space and measure the air temperature in the space to give feedback to the boiler. Even if you don't have a Vitotrol, this room adjustment is what the homeowner uses to make adjustments to his system. He can change the room set point, whether it's a real number or whether it's a virtual number, and he doesn't have to understand any of this thing. He doesn't have to understand a heating curve, slope, or shift, or any of that stuff. So in a heating circuit, you have a room adjustment temperature, and that's what this line here is. If you have a heating zone, or what we call a zone circuit in the last group, you don't see any room adjustment, because heating zones or heating circuits are designed to operate with a thermostat in the space. So a regular traditional thermostat. So that means that you're going to need a thermostat. So when you set the boiler in a weather compensated mode, you set a heating curve that doesn't have the room adjustment in it. And what you see on the display is the calculated boiler water temperature set point. So you can have a choice of weather compensated or not weather compensated, even on the heating circuits now and the zone circuits. It used to be the heating circuits were always weather compensated. You have a choice now. So with or without. So a heating circuit can be with or without weather compensation, and it's not designed for a room thermostat. So it's going to have a fixed set point, which means that you're going to have a water temperature set point that you're going to set. If you're going to use outdoor reset, then you're going to have that room adjustment on the screen, but you're going to set the heating curve. So the heating curve, again, remember, for a heating circuit has the room adjustment parameter. With a heating circuit, you can use the Vitodens 200E room controls. That gives room feedback, and it also gives a real room temperature to the boiler. And a heating circuit may have a mixing valve or not. If it's heating circuit 1, it will not have a mixing valve. If it's heating circuit 2, 3, or 4, it will have a Viessmann controlled mixing valve. A zone circuit on the other side of the idea is that it can be weather compensated or not, but it is designed to have a room thermostat. The room thermostat is the master room high limit, you can call it. When the room's hot, it turns off that loop. It'll turn off the pump that's associated with that loop, and it will say, don't make heat right now. It will take that set point out of the boiler because it'll say, I don't have an active set point, and the boiler will go to another set point, the next highest set point if there was one lower than it. If you're not using the zone circuits with thermostats, you're using traditional heating circuits, or if you're using not all of them, the zone input 1, zone input 2, and zone input 3 can be used for safety limits. So a low water cutoff, a low gas switch, or a high gas switch, and they're not choosable. Your zone 1 is low water cutoff. So if you needed a zone circuit and you needed a low water cutoff in your area, then you would start with zone circuit 2 for your heating loops. Now, on the concept of low water cutoffs, traditionally in all of our Vitodens 100 and 200 series boilers, right back to the very first generation, they were certified for use without a separate low water protection device. We have documentation from CSA International that says that the boilers meet all the requirements under CSD1, and CSD1 is the document that's produced that we build boilers to have all the safeties and everything else in it. Every HVAC equipment, every boiler equipment has to fall into the categories for their particular type of appliance. And with these appliances, because we have an internal flow proving and we have two temperature sensing devices, they don't need an external low water cutoff. I would expect we're going to get the same certification on these boilers because they're identically in the way they operate. I haven't seen the letter from CSA yet, but you can say that, well, I expect to see it coming. We can provide that letter from CSA International to you, so it's valid in anywhere in North America. You may still have an inspector that says, I don't care what letter you got, my interpretation of my local gas code, you have to put a low water cutoff in. And we see that periodically. But okay, so if you need that, you can use the zone circuit 1 as your low water cutoff point. If you want to use 1, 2, and 3 for zone circuits, you can always hook the low water cutoff into 96 as external blocking or into the main power to shut the whole boiler off. So that could have been a choice you did when you set it up. The zone circuits are not designed to use Vitodens. So the Vitodens we saw, the Vitodens 200E idea we saw in HC circuits, we do not have that ability in here because you're putting somebody's thermostat in the room. And heating circuits, or heating zones rather, do not use a mixing valve. If you want to use a mixing valve to limit the temperature, it would be a thermostatic valve just to cap the water temperature of a certain level. Remember, the boiler is going to make the hottest water of any active set point. So if you've got two loops that have different heating curves and they're both calling for heat, the water coming out of the boiler is going to be the highest temperature. So if you have an area where you want to protect the floor from being too hot, you can put a thermostatic mixing valve in that loop, and we'll show you some applications of that as we go through. I'm going to run this little video
At the
here
heart of the weather compensated
about
control
heating curves.
is the heating curve. To do it right, you will need to know a few things. The first thing is where you are. Different places in the world experience different heat loss due to local weather conditions. The next is what type of heat emitters are being used. Some heat emitters need a greater water temperature to deliver the same amount of heat as others. Third is the building construction. An inefficient, poorly insulated building will lose heat faster than a well-insulated, highly efficient building. And lastly, maybe the hardest thing, is who occupies the space. Different types of people have a different idea of what feels warm to them. Let's take a look at the various parts and how they are used. At the bottom of the chart is the outdoor temperature scale. This would be the temperature that the outdoor temperature sensor is seeing. On the left-hand side of the chart is the boiler water temperature scale, or in some cases the loop temperature. This is the calculated water temperature that the system will get from either the boiler or the mixing valve. On the right-hand side and wrapping around the top is the slope scale, with each number attached to a line which focuses on the anchor point on the bottom left of the chart. Along the left-hand side of the chart, we see a scale marked shift. It is a vertical adjustment, and when you make an adjustment to shift, it grabs the anchor point from whichever line you've chosen and moves it up or down vertically. The range is -13 to 40 Kelvin. Kelvin is a measurement of absolute temperature, and 1 Kelvin is equivalent in size to 1 degree Celsius. Making a change of 10 Kelvin is essentially making a change to your set point of 10 Celsius across the entire slope line that you've picked. The final adjustable parameter is the room set point. This is designed as an end user value. It moves the anchor point up and down on a 45-degree angle based on a desired room temperature. This may be a virtual temperature or a real temperature depending on the hardware installed. When you set a value in slope, you're essentially picking one of the lines off the chart. The control will allow you to set a number between the designated lines. As you can see, when you make an adjustment to the slope setting, the anchor point on the left doesn't change. When you change the number, you essentially pick a different line off the chart. The higher the number, the steeper the line. And with a steeper line, you get a greater water temperature change for the same reduction in outdoor temperature. Minimum and maximum limits can also be set for individual heating circuits. These settings come in handy if you want to, for example, set a minimum temperature for a high temperature baseboard loop or a maximum temperature for a radiant floor loop. With all the settings at default, with a -20 outdoor air temperature, the calculated boiler water temperature is 74 Celsius. With a warmer outdoor air temperature of 0 Celsius, the set point is reduced to 50 Celsius. And at 10 Celsius, the calculated water set point is 38 Celsius. So let's leave the slope at 1.4 and make an adjustment to shift and see how that changes the calculated set point. Adjusting the shift parameter moves the entire selected slope up or down the vertical scale between +40 Kelvin and -13 Kelvin. 1 Kelvin is equivalent to 1 degree Celsius in size. Inputting a shift of 10 Kelvin now increases the calculated set point by 10 Celsius across the entire line. The final adjustable parameter is the room set point. This parameter allows the end user to make an adjustment to room temperature, which is something they understand, as opposed to having to understand the heating curve. As a virtual number, this value is set at the boiler. If a Vitotrol is actually installed in the space, the room set point can then be set at the Vitotrol, and room feedback is possible to the boiler so it can customize the set point based on actual room temperature. When making an adjustment to the room set point, it takes the selected slope line and moves it up or down the scale on a 45-degree angle between 35 and 5 Celsius. If we adjust the room set point to 25 but leave the shift and slope at the factory default, we can see that the adjustment isn't linear across the whole line. In the case of this example, at -20 we are actually 10 degrees higher, and at 10 we are actually 10 degrees higher. But at 0, there's actually a 12-degree increase in the set point, higher than the factory default. Slope, shift, and the room set point are all used to fine-tune the calculated weather-compensated set point. For Viessmann heating circuits, the contractor settings are slope and shift, and the end user sets the room temperature. Our residential boilers using Vitotronic controls also have zone circuits. These operate a little different than the Viessmann heating circuit. A zone circuit is designed to operate with a traditional thermostat. This means that there is no room set point within the control, and the Viessmann Vitotrol is not compatible with a zone circuit. When using zone circuits, the contractor settings are slope and shift, and the user settings are what's available within the thermostat for scheduling and room temperature set point. Remember, when setting heating curve parameters, you not only need the design load day, the coldest day of the year you expect to see, you should also know the system water temperature required on the base load days, the warmest day of the year you expect to need heat. So now, let's look at 3 system design examples and some possible heating curve parameter settings for each. We will use an outdoor air temperature range between 15 and -20 Celsius. System example 1, boiler water temperature set point range will be between 30 and 71 Celsius. The factory default heating curve settings are slope 1.4 and shift 0 Kelvin. Adjusting slope to 1.2 and shift to 4 Kelvin gets us pretty close to the range we desire. We could make further adjustments, but remember, this is boiler water temperature set point, not rocket science, and a couple of degrees on either side isn't going to make that much difference to the ability of the heat emitters to deliver the right heat. For system example 2, the boiler water temperature set point range will be between 40 and 85 Celsius, a little bit warmer than our previous example. If we set the slope at 1.5 and the shift at 9 Kelvin, you can see we get pretty close to where we want to be. And because of the building mass and other variables in the system, this is probably close enough. For system example 3, let's look at a boiler water temperature set point range between 20 and 45 Celsius. This is cooler than the previous 2 examples. Perhaps this is a radiant floor heating system. Setting the slope at 0.8 and the shift at -5 Kelvin gets us where we want to be. Also notice that when we use a negative Kelvin shift, the warm weather shutdown point changes as well. In this case, the warm weather shutdown point is moved to 15 Celsius. That means above 15 Celsius outdoor air temperature, the heating system will be disabled. But remember, you need to know some basic information to get the system settings correct. You need to know your design load day, but you also need to know your base load day. You need to know what water temperature is required to deliver the BTUs needed from your heat emitters. You need to know how well the building is going to hold the heat you send it, and you'll need to know a little bit about the comfort preferences of the people who occupy the space.
So that video was built around the Vitotronic controls. You heard me reference the Vitotronic controls. There'll be another version of that. I just quickly did an edit on this for this presentation. There'll be another version for the E3 series controls, which will be a little bit more specific to the E3 concept. So next thing is your domestic hot water. So it's going to want to know if you have it. So you say, I have a domestic hot water. I don't, not installed, not available. Whether I have a tank and the tank has one sensor, whether I have a tank with an aquastat, that's down here farther, storage tank with switch. Whether I have a recirculation pump, this is going to be expecting to see a recirc pump taking the water back and forth from the tank to the taps. So these are choices you make in the control right now to tell how the domestic is going to be set up. And it's the same thing on the app. The app will give you a buffer cylinder as well. I think they're probably going to add that to the main control. It might already be there. It wasn't in the screenshots I had. But a buffer is different than a low loss header in that it has more mass, right? So if you have a low mass boiler, you can add mass to the system by putting a buffer tank in it. And you would just basically use the buffer tank as your primary, secondary, or hydraulic separator instead of the low loss header. The low loss header is going to add a gallon or so. Maybe a buffer tank adds 10 or 20, depending on what size of tank you put in. The idea of the buffer gives more mass. It allows the system to compensate for a house that has tons of zones. So you got lots of little zones in the house. And on a low mass boiler, that drives the boiler crazy because it doesn't see a load big enough for its minimum firing rate. So it cycles a lot. As soon as you have the buffer tank, you slow all that down because it's heating the buffer. The reason why you want to tell the control you did that is because it knows that it's dealing with more than just a gallon or so of water in the mass of the low loss header. It anticipates the loads differently. It slows it down a little bit. So a degree temperature drop in the tank doesn't mean the boiler has to jump on it right away. It knows it has some mass there. So this just allows the boiler to slow the process down a little bit when you have added mass to the system. So the external demand for the plug 96 function, this is a dry contact input on the control. It will have no function, and if you don't do anything with it, that's what the default is. External demand, which means that when it sees that contact close, it adds an extra zone essentially. So we have heating zone 4. It doesn't have a pump directly connected to this. So whatever you're hooking up to heating zone 4 would have to have circulation from somewhere else. So it might be a snow melt or a pool or something like that, or an air handler with a pump inside it. Those are kind of things we look at, and it would be a fixed set point. So this set point then is set in the addressing for the 96 plug. It could be external blocking, which means that it will shut everything off. A closed contact at external blocking means, hey, we're not doing nothing. We're not doing hot water. We're not doing heat. We're not doing frost protection. We're not doing anything. And again, this would be an alternate place. You could hook up a low water cutoff to it. What you have to remember here, though, is that it's a closed switch means stop. So if you're using the low water cutoff, you want the other side of the switch on the low water cutoff or a relay in there to say, when the low water cutoff trips, we close this contact, right? And call for heat. This basically uses it as a room thermostat input. So we can have an extra input for the call for heat. Next thing we can do is set our maintenance schedules. So maintenance schedules will give the homeowner reminders when it's time to have their boiler serviced. They used to put these reminders in the fault codes, and we historically, that's not my favorite choice. Because when a homeowner sees a fault code come up, they think it's an emergency. They need to have something done right away. So they'll call you, and you have to kind of jump through hoops to get there in a hurry to find out it's just, oh, it's time to service your boiler. So they've moved this into a different menu in the control now. So it's more like a notification than a fault. And you can leave it off if you don't want to have any reminders. You can set the reminders by a months of operation, or you can set the reminders by hours on the boiler. And this will then give them a little flag that says, hey, your boiler is due for service. A lot like your car nowadays, a lot of the modern cars nowadays have a little reminder that tells you when you need to change the oil based on how far you've driven or whatever. So this is the boiler equivalent of that type of thing. Whether you have a Vitotrol or not, the control can officially support 2 Vitotrols because it powers the Vitotrols on the plus bus. The control will ask you for 4 Vitotrols because you can put one on each of the 4 heating circuits. But officially we support 2. We are going to play with that a little bit at Viessmann Engineering in Waterloo to see if we can actually support more than that. But officially, according to the programming or the design engineer, that it's a 2 Vitotrol support currently. The next thing is, what do you have for heating circuits? One of the challenges we always had with the last generation was that you always had heating circuit 1. You had an outdoor reset or an outdoor air temperature, and you always had heating circuit 1. So if you didn't need heating circuit 1, you had to go in and set the control of heating circuit 1 to a minimum temperature so that it didn't interfere with the other calls. Now we can turn it off. So you can have no heating circuit 1. Why would you say no heating circuit 1? Well, you might have 3 zones you want mixers on because you got a zone circuit and you want 3 with mixing valves, or you just want mixed circuits. This way, heating circuit 1 is a non-mixed circuit always. Heating circuit 2, 3, 4 are always mixed circuits, and you will only see those in the control if you have the hardware for the mixing valve connected to it. So you can say, I don't have heating circuit 1, all the way up to heating circuit 4. I do or I don't have them. If you're going to use 2, 3, or 4, like I said, you need this Ea1 module, hardware module, which gives you control, gives an input for a temperature loop sensor, a pump, and a mixing valve for that loop, and communicates back to the boiler on the plus bus. The other thing we have is zone circuits. So again, now we're checking, do we have zone circuits? Remember, the zone circuits can be thermostat input, or they can be some safety limit. These will now power a 24-volt thermostat. In the previous generation for the zone circuits, it had to be dry contact. It didn't have 24 volts on it. Now we have a 24-volt circuit, a common, and a W terminal on the zone inputs. So you can use a traditional powered, what Scott calls power robbing thermostats. You can use those inputs here. And you have a choice of what are you going to do with it? Thermostat, low water cutoff, whatever you're going to do with it. It's 1, 2, and 3. And you're really done. you've now set up the boiler for potentially 4 heating circuits, 3 zone circuits, an external demand or an external blocking. All of that's been done with domestic hot water, with a tank or with a sensor. And all of that's done without ever going into coding. So this is the idea of simplifying the process here. It's going to say you've done, it's going to do the same thing now. It's going to ask you in both the HMI and in the app here if you want to connect the boiler to the internet. So this is where you're either going to need some information from the homeowner, or they can do it later themselves. If they don't want to give you their Wi-Fi password, they can do it themselves. But in the app, in the Vitoguide app, it's going to say, I want to activate the online services, or no. If they won't give you the app, say no, and password rather. If they say yes, and then it's going to look at all of the Wi-Fi networks it can see. And you guys know when you go over to your buddy's house, you say, hey, Bob, what's your Wi-Fi password? And he says, it's Bob's house. And you go onto the network, you say, Bob, there's like 12 Wi-Fis here. Which one's yours? Or he says, it's the one that says Bob's house. And you go to the SSID for Bob's house and you put in Bob's house password. And you then click OK or confirm in this case. And what happens is now the boiler, you have told the boiler, this is the network you belong to. It will go and ask the network for its own password or its own IP address, and it will say it's connected. Now, this connects the boiler to the homeowner's router. There's one step farther than this, is that it needs to now connect the boiler to the Viessmann network. So that sometimes takes a little bit. You can get this connection right away as soon as the boiler, but then it's got to go find, got to really search the World Wide Web for the Viessmann network and put itself on the Viessmann network. And once it's done that, then you can access the boiler through Wi-Fi, either with a Vitoguide remote or with the VCare app or the Service Assistant app, which is what the Viessmann technicians are going to use. Part of the installation process for the Wi-Fi is to put the homeowner's information in for VCare. Again, if they don't want you to do this, they can do it themselves later. This is all can be done by the homeowner to put all this information into VCare. You can do it for them through the Vitoguide app. Now we've got just some housekeeping things here. So we say, do we want to make noise when we push buttons or the alarm, that kind of thing? Do we want the light guide? The light guide is a red indicator light that's on the front of the boiler controller that tells you what's going on, and we'll talk about that a little bit at the end here. The screen brightness, depending on where your boiler room is, you might want it brighter or dimmer, depending on how bright your boiler room is. In our lab upstairs, we have a control on a boiler that's sitting right below skylight. So at noon, you can't see it unless it's at full brightness. But if it was in a boiler room downstairs in our boiler room, you'd want it dimmer because you don't want to light up the whole room and it's hard on the eyes. So this way you can adjust that. Whether you want to lock the screen, you can lock the whole control, or you can lock just so you can see the dashboards. And what's the default dashboard? So remember, we had the choice of the domestic, the heating, or the overall view. So these are choices you make here. Again, these are the 3 choices here for the dashboard. So you have the choice of if you're looking at a heating circuit or a zone circuit, there it is. If you're looking for DHW, it stays on this screen. And this is the one that I would prefer myself. It gives me the burner operation. It gives me the outdoor temperature. It gives me the boiler water temperature. All of these things are part of the home screen, so I can see easily. If I see this little blue square with the Wi-Fi symbol with a stroke through it, somebody's turned the Wi-Fi transceiver off. So the homeowner can't get on the internet, say, hey, I can't talk to my boiler. You can say to them, is this a little item, is this a little icon on the screen? Yeah, well, somebody's turned the Wi-Fi off. They can turn that on without having to go into service menus. The actual Wi-Fi is going to show up here. It's actually connected to a network. In the top right-hand corner beside the time and the date, you'll see the Wi-Fi symbol, and it'll be like your phone. It'll give you a strength indication of how many lines are on the little symbol. Connected to the plus bus is the internal network. So it's all of the Viessmann devices talking to each other. It is not where the cascade of the boilers that's doing cascade talks to the other boilers. It's not where the boiler talks to the internet. It's not where the boiler talks to the gateway for a building automation system. This is the internal control bus. We used to call it a KM bus. The plus bus has a much higher level of security in it, so we moved to plus bus. And you can have up to 7 modules on the plus bus. And what we show here is we show 1, 2, 3 M1s, which are mixing valves. We show an external pump module, which gives us functionality for more pumps. We show 1 solar module, which allows the boiler to control the solar heating, the solar thermal system. And we show 2 Ea1 modules, which are expansion modules. And also on the plus bus, you can have up to 2 Vitotrolls. Again, we're going to play with this to see if we can expand on that. But right now it's 2 Vitotrolls. Each module needs to be addressed. So in the case of an M1, which is a mixing valve module, you can see that it has a power cord. It has an output for the pump for that loop, an output for the mixing valve for that loop, an input for the temperature sensor for that loop. And then we can hook up the plus bus, and it's just a daisy chain from one to the next until you get to the end device. But you need to set the rotary switch to identify which unit this is. So 1, 2, and 3 represents mixing valve or heating circuit 2, 3, and 4 as you set the addressing. When you have the pump module, what it does, it gives you functionality for 2 more pumps. And you would set this dip switch also at 1, 2, or 4. It's at 3 or 4. It can be, it's set basically after the mixing valve. I'll talk about that, come back to that in a sec. And if we're using the solar module, it's always at 0. You notice that these circuit boards look the same. All the hardware connections, X2, X4, X5, these are all the same nomenclature, but we use them for different purposes. This is part of Viessmann's platform now, that reducing the amount of parts required in the boiler. It's cheaper for us to manufacture 4 boards that look the same and put different software on them than it is to produce 4 separate circuit boards. So the whole idea of having less replacement parts, less manufacturing parts, and it's the same between 100s and 200 series boilers up to 199,000. A lot of the parts are the same. And the last one is the Ea1 module. This is the one that looks different. It has a different circuit board. And if you remember the older Ea1 module on the current, or the current generation Vitodens 200, we had 3 DI inputs. We had a pump output, we had alarm output, we had 0 to 10 input. These are the things that we still have on this module. We're not going to use this near as much as we do with the current boilers, because almost all that same functionality is in our boiler now with our zone inputs. The Europeans don't have the zone input 1, 2, 3 that we have. So they need this anytime they want to do some expansion. There will still be some functionality for this, but it will not be used as near as extensive as it was in the existing boiler. We had to include it in the existing boiler to make it work. So we can do up to 4 heating circuits, up to 4 heating zones, previously zone circuits. So when you go into the control, you say, what do I want to look at? I want to look at the heating circuits. I want to look at the heating zones. And you can see the information scheduling, which doesn't exist in a heating zone because the scheduling is in the thermostat. So we can see the various information for those things. So when we set the heating curve, we got slope and shift. And we talked about that in the video. You saw how that works. And this is what it looks like on the HMI. Scheduling. We have an additional schedule in here now. Now, if you remember the older controls, we had party mode and eco mode. And party mode was usually champagne glasses or a martini glass. And that's why, I guess, why they call it party mode. And eco mode was, depending on the generation of the boiler, was either wavy, a green leaf, or it was a piggy bank. That's been changed now. So we have reduce, which we always have. We have normal, which we always had. We have comfort now, which is the third schedule if you want to use it. So think about it this way. Everything that's not normal or not comfort is reduced. So I never have to program reduced. If I look at a traditional, let's say a Honeywell thermostat that has wake, leave, return, sleep, you have 2 on, 2 off. Well, what we've done is we've said anything that's not an on is already an off. So why would we have to put a number in for that? So you only program either comfort or normal. And you don't have to program comfort at all. But look at it from a perspective of this way. My normal function could be my regular daytime schedule. My comfort function might be a time of day when I want to either increase or decrease the heat from my normal, but not put it in the setback. So maybe in the morning when I get out of bed, I like my house a little bit warmer, so I can do a comfort schedule from 6 to 8. Then from 8 to 5 o'clock in the afternoon while I'm at work, it's going to go into reduced mode. I don't program reduced mode. And then when I come home in the evening, I want it in normal mode, which gives me a different room adjustment value. And that's what these numbers are. They are the virtual or the real room adjustment values, right? So you're putting in your schedules. Remember, anything's not an on is an off. And you put it in based on the time clock. If you don't want any schedules at all, you would put them from 0 to 2400, would make it daytime all the time. Or you can set all these temperatures the same either way. If you do this for every day of the week, but if you want to copy days, so you say, well, Monday, Tuesday, Wednesday are the same. I do work a different schedule on Thursday and Friday. You could just copy Monday, Tuesday, put the program into Monday, copy Tuesday, Wednesday, and just copy and paste, and would duplicate those for that day. So you end up with different schedules. Your DHW can have its own schedules. We have a temperature schedule. We have for DHW, we have a time program for DHW, which says when the DHW is active or not. We have a recirc program for the recirc pump. We also have this hygiene function now. And the hygiene function is you pick a time and you pick a day, and it will heat the tank up hotter during that time period. And the idea is that if we have a tank that's running a little cool because they want to keep it cool, then this will give me the ability to boost that temperature, make sure that I drive all the bacteria out of it at least once a week kind of thing to make sure nothing grows in the tank. Sorry, oops. One other thing we had is what they call scald protection. Let me come back to that in a little bit, because this is a set point value, and we'll show you that in coding. Available options through coding. Well, we can decide what we're going to do with external demand. So external demand, it has a set point. So remember, it doesn't have a pump function necessarily, but it does have a set point. So you have the set point set in here, and the most common application we see is a pool or a snow melt. And those are the things that we use. And you set that external demand. So if you program that 96 plug for external demand, this is where it's going to say, what temperature do you want me to do at external demand? This is a new feature, setting the gas parameters. This is a really cool feature for the homeowner, because they can go to a menu to see how much gas this boiler's consumed this month or last month. But you have to have the right information in front. You know, the old term garbage in, garbage out. This information on the gas volume correction and the calorific value, this comes from the gas utility. A lot of gas companies will put that number on their gas bill. My particular region doesn't, but I can call the gas company or send them an email and say, what's these values? And they will give them to me. If I put into address 1098.4 and 1098.5 the right values, it will know by how many hours and the modulation on that burner, because we have the mass airflow sensor and we have the Lambda Pro combustion management sensor, it will know the gas consumption of that boiler. And it will be able to report that gas consumption to the homeowner on a menu. They can also see that in the app. I think when they see it on the VCare app, it kind of gives them a graph so they can see the difference. So again, to make this work accurately, you have to put this information up front. The other thing we have, which is a neat feature, this was in the older boilers as well. Now, when we get to this point, I want to point out something here. The addressing for coding is no longer in hexadecimal. Hexa what? Hexadecimal. Hexadecimal is the way computer brains think. They think in blocks of 4, 8, 16, 32, 4, 64, 128. And we can thank people like Bill Gates and Wozniak for those kind of ideas, because when they were building the first IBM processors, they built them in on-off blocks of 4, 8, 16, 32. So in the background, hexadecimal is the way we store information on the chip. And if you've ever had your laptop or your desktop crash and you get what we call the blue screen of death in Windows, and it gives you this hieroglyphic block of letters and numbers. Those are hexadecimal numbers. And when the older generation of this boiler, all the coding addresses, all the fault addresses were listed in hexadecimal. We asked the engineering to find a different way to do this for the display part of it. This still has hexadecimal in the background. It's just the way computers are built. But what we've done is we've converted the hexadecimal numbers to digital numbers or decimal numbers in base 10, which is the world we live in. So these coding addresses show up as base 10 numbers now. And the reason why I point that out is because this feature here was in the old boiler at F8 and F9. Those were the addresses for it. So what this is a way for the boiler to push itself out of setback when the outdoor air temperature is below what we normally expect it to be based on our design day. Now, the defaults are a little bit high because this is -5 and -14. And for most places in Canada anyways, that would be too cold, or sorry, too warm for our environment. What you want to do is set this number here close to your design day. So in where I live in Waterloo, we have a design day according to ASHRAE of -21 Celsius. That's -4 Fahrenheit roughly. And so we would set this at maybe -18 or 19 or maybe -20. And we would set this one a little bit colder than that. So what happens over here, if you look at this default of -5, at -5, this is my nighttime calculated set point based on my reduced room temperature. This is my daytime calculated set point based on my normal room temperature. And when it goes into setback, this line here, what the control does is it pushes the adjusted room temperature down. That's how we achieve setback. And if we have a real Vitotrol in the space, they can use the Vitotrol to get feedback. But in this case here, what happens is during the daytime, it runs at the dotted line here. And at nighttime, it runs at the pink solid line down here. But at -5 degrees outside, it starts to work its way back towards the daytime set point of -14. At -14 outside, it's running back at the daytime set point. So if I have a scenario, we've had a few ideas like that over the last few years where, our design temperature is -20 Celsius, -4 Fahrenheit. But, for 3 weeks this last winter, we had days that were -30. Well, that means that when the boiler comes out of setback, it's going to be a little bit difficult for the boiler to operate because it's going to take longer to recover. In a lot of controls, I use a value they call optimization. And optimization looks at what it did yesterday to try to figure out what it should do tomorrow. And that doesn't work very well in any of my experiences. When I was doing building automation stuff, we would always turn that off because, today could be -4, tomorrow could be -20, right? So what we have is a scenario where when it gets to the setting, and we'll say in my neighborhood here in Ontario and Waterloo, that I would set this a -18. And at -18, it would start to push its way back towards the daytime set point. By the time it was -24, 4 or 5 degrees below my set point, I'd be running at the daytime temperature and I wouldn't get behind. The boiler would anticipate that it's colder than normal and I need to start warming the heating system up a little bit more. That is one value we can make an adjustment here. I'll come back to a different one after in a little bit, which gives us another value in this type of an adjustment. Interval and runtime. So this is maintenance. Again, we can set basically the values in coding. We set those in the menu, but we can also come back to coding later and do it if we want for either hours on the boiler or months. We can set a maximum input separately now for heating and domestic. So I might have a heating system that will need to be full capacity. My domestic is less. Or maybe the other way around. We have lots of new houses nowadays that the DHW load is bigger than the heating load. So we want to have the full 125,000 BTUs for heat, but we only need, or for domestic, we only need 70,000 BTUs for heat. So I can set a maximum percentage. So if this is 120,000 BTUs and I take it down by 10% to 90%, it's now 12,000 BTUs less. And I can do that separately for heating and domestic. So you can set those two addresses individually. The speed of the primary pump is adjustable. This is a variable speed ECM pump, and it will do some automatic speed adjustment, but it is really something you're going to dial in. So you're going to set up the speed. Now, how do you know that? We're going to walk through that a little bit later when we talk about the pump speed closer to the end, but you're basically going to set a percent, and it's going to follow one of these pump curves. Now, this is for the heating mode. We have a separate setting for domestic, which we'll come back to in a second. We also have a minimum input. So this takes the BTUs at the minimum firing rate and pushes it up. So maybe I want them bigger than at 8,500 BTUs in this case. Maybe I want 10,000 or something like that. I can move it up in increments all the way up to 100%. If I don't want the boiler to modulate at all, I can set it at 100% and then it always runs at its max, right? I don't know why you'd want to do that, but it is possible. Now, this is global, the whole boiler. This is DHW and heating as a minimum number. You can adjust those independently. Boiler coding in here of 1606 and 1606.4. This is what we call pause time and integral. Pause time is how long the boiler has to stay off when it's turned off. So once it completes the cycle. So it's hit a set point, boiler turns off. We don't want the boiler cycling back on too quickly. Too many starts and stops is not good for anybody. Efficiency, boiler management, maintenance, all that kind of stuff. So there is a minimum time. The default is it follows the integral value at this address 1606.4, or you can switch it to a minimum time, which is a fixed number, which is not adjustable. It's set in the background of the coding addresses as a very minimum that the boiler should be off to keep the boiler running without hurting itself. Integral threshold is how it calculates that time automatically. So we leave this at 1 and we set this number at the default of 50. And you look at this description here and it says factory setting is 90 Fahrenheit times minutes or 50 Kelvin times minutes. What the heck is that? Integral value is a measurement of historical error. It's comparing the actual to what it should be on a routine, regular counted basis. We have minutes in here. It could be minutes, hours, seconds, decades. It could be any number, but it has to have a time value in here. So the easiest way to understand this is that it's a count. If I have it set to 50, I look at the set point in the actual and I count to 50 and I look again and I see, did I make any ground up or did I lose any ground or am I expected to be where I am expected to be? If it looks and says, hey, I expected it to be closer to the set point and it's not, it can actually reduce that time. Now, the integral is built into every logic loop in your cruise control in your car, in the boiler water temperature calculation, in the burner modulation calculation. This particular one is about start-stop function. So if I have a boiler that is cycling too fast, when it turns off, it comes back on too quickly. I make that number bigger. If I have a boiler that's cycling not enough, so it takes too long to come back on, so I'm losing too much temperature in the loop for that minimum off time, then I want to make that number smaller. So think of it as a counting number. The bigger the number, the higher I count. The longer, higher number I'm counting to, the longer it takes me to get there. So it's going to make reactions slower. I'm looking less often. So if I make the number smaller, it takes me less time to count to 10 than it does to count to 50. So I'm going to make that number faster. Do little adjustments on this. And when you make an adjustment to integral, you have to be patient because remember, integral is historical error. What it did now compared to what it did a whole bunch of times before that it looked. So if you make an adjustment, the history's gone, right? If you change it from 50 to 10, you're not counting to 50 anymore, you're counting to 10, so it has to start again. So any integral change you make here is a lot of cycles before it will you'll actually see a difference. So what you need to do is make little adjustments to this and see what happens. Functions of the output. So we have two inputs here. We have a 0 to 10 input, and we have a dry contact output. And these two items happen to program at the same coding address by what you do with it. So when you set 1706.0 at 1, it has no function. So there's nothing going on here and there's nothing going on here. If you set it to 3, then the 0 to 10 is a temperature demand. So a set point. I can set the set point. So 0 to 10 volts DC represents 0 to 100 Celsius as a set point value. And this is how I can get an extra input into the boiler. It doesn't have any function for the plug, the binary plug. If I set it to 4, 0 to 10 is now burner modulation. So this is something new for this controller. You can actually say to the boiler, if it was tied into a commercial system, you could say, the burners, I want the burner at 20%, I want the burner at 40%, I want the burner at 70%. I'm not a big fan of this because it's like your wife telling you what speed to drive when you're in the truck and she's at home, right? She doesn't know what's going on in the street, but she's telling you, put the foot on the gas pedal, buddy, because you got company coming, right? So this way, not my favorite method. I would rather give the boiler a set point and let it do its thing. Or we can make this contact here be a fault alarm. So anytime there's a fault, we get a dry contact, ring a horn, honk a bell, do something with it. But the 0 to 10 has no function. Then over here we have the external message and temperature demand. So this is a set point and this is an alarm. Fault message and modulation. We have additional functions here for, again, we set parameter 2445. Call for heat and 0 to 10 modulation, call for heat and 0 to 10 or 0 to 10 temperature. So those are the two options there. So you just decide what you want to do with these 2 points and you program it. Remember, any of these coding addresses, this doesn't matter really. The boiler will operate within you making any adjustments because you did all the stuff ahead. This is to tweak and fine tune and customize, right? Operation of the DHW pump by time program or by cycles. If you set it by cycles, then you pick the number of cycles. How often do you want it to run? This is the anti-scald function. So the hygiene function. So when do you want the hygiene function to operate? And we saw earlier that that's the schedule we chose into that. A recirculation pump in accordance with the selected time program or based on the target value. Anti-scald. This allows you to kick the set point up. So the maximum operating set point is 140 degrees with the anti-scald on. If you turn it off, the tank temperature can go, I think it's to 160 degrees. This is if you want to keep the tank a little hotter. There's maybe some advantages to that. I know in Canada, every plumber has to put a tempering valve on a domestic hot water tank anyways. So if you use the anti-scald off, then what you have is you have water sitting at 160 instead of 140, and you can maybe solve a little problem you had because you picked a little bit too small a tank for the family. It keeps the water hotter. It blends more with the diverter valve or the tempering valve. So this is where you can turn that on and off. This is the starting point for when it goes through the set point. Again, in Kelvin, the 2.5 Kelvin is the default. Setting at 25 is 2.5 Kelvin. Remember, 1 Kelvin is the same size as 1 degree Celsius and 1.8 Fahrenheit. We use Kelvin for reference values, so differentials or like the slope and the shift values rather, because they're not real temperatures, they're reference temperatures. If we use the real world temperature, people get confused with, oh, I set it at 20, why isn't it at 20? So it's a differential. What this means is that when the boiler, when the cylinder drops to 2.5 Kelvin below the set point, that's when it initiates the call for heat. Maximum duration for DHW, this is also a new setting. So we have a new setting here, which means that when we make DHW, the default is 60 minutes. If it can't satisfy this tank in an hour, it turns the domestic function off and goes back to building heat. Once it's off, how long is it off? That's this next setting, address 1087.1, the minimum delay before it tries again, which is also set at 60 minutes. So it will heat this tank or try to heat this tank for an hour. If it can't satisfy it for an hour, it goes back to heating for an hour, and then it goes back to try to do domestic hot water. And you can make adjustments on these numbers to suit your application. Normally, when we need this function, there's two things that happen. One is there's a plug in the coil of the tank, or the line's not big enough, or we didn't anticipate the head loss across this tank, so the pump's not big enough. Those are all things that we see causing long DHW calls with no satisfied tanks. So this allows us to get around that if you have to. We've never included this before because our mindset has always been, well, if you size it right and it isn't broken, and if it is broken and the building starts to cool off, you might want to know you don't have any hot water. But it was a request that we got from the tradesman. Now, we talked about the speed of the primary pump. This is where I set it for heating at 1101.2. Or sorry, 1100.2 was the heating. Remember, we saw that before. And this is for the DHW. We can set a different primary pump speed for both. Now, why do we want a difference? My head loss between my boiler and my low loss header is probably lower than the head loss between my boiler and this tank, because there's high resistance in the tank too. So if maybe I want to have this pump running for DHW at a higher speed, you can do that by sizing the load, right? And we'll talk about that a little bit later. This is the other coding address I talked about with setting up functionality for getting out of trouble on a cold night. These two addresses here allow you, this is my nighttime calculated boiler water temperature. This is my calculated daytime boiler water temperature. And if I set this value at 0, it doesn't do anything. But if I turn it up here to 20, let's say in this case here, we've got 10 degrees Celsius. So let's say I set it at 10, right? When it comes out of setback, instead of walking around at this temperature, it's going to boost it 10 more degrees for the duration of the time, which is this address at 60 minutes. After 60 minutes, it'll go back down. So it's like a morning warm-up. It gives you a little bit of a kick in the morning for an hour or whatever you set it to try and get over that recovery of energy so that we have the minimum amount of time to reheat the house in the morning. Sorry, I had to take a drink. My voice was getting tired. Okay. Domestic priority. We can set domestic priority on or off for the 3 heating circuits. With zone circuits, domestic is always a priority. But we can set it to turn on and off on priority on the heating circuit. So you're going to have domestic as a priority by default, and you can turn it off if you don't want priority. Most of the times you're going to want default as priority. But there may be applications where we've sized the water properly and we've piped it properly to make no priority. And for the heating circuit 1, 2, 3, and 4, you can take the priority off or put it on. With the heating circuits, you can also set minimum and maximum temperatures. We talked about that a little bit in the video. So this is my outdoor reset curve. And I say the minimum should be 40 or the maximum should be 80. It will, as soon as it comes to a warm weather setback or warm weather shutdown rather, it jumps to here and it will run to here till it reaches the point where we're going to increase the temperature anyways. Then it follows the heating curve. When it gets to here, if it got colder outside, we'd see this happening, but we're going to flatten it on the top. So this you might set as the minimum number for say copper baseboard heat, which is not going to give me any convective current below maybe 115 or 120 degrees Fahrenheit. And this could maybe be a radiant floor or a panel rad that we don't want to be too hot, so we can set the maximum. So going outside the design temperature of the colder days, or somebody turning the room temperature way up. Somebody set the room temperature to 35 or 70, 78, right? This is going to cap that operating water temperature so that it doesn't overheat the floor or the panel rads or whatever, right? So that's what these two numbers are. So those are all the customized numbers. What we're going to look at now is some applications on how we would pick things to set them up. So this is the first one. And all these applications are going to be available in the new application guide. We have an application guide in Canada already for the existing boilers, and this is basically built on that same kind of a platform. I created a bunch of drawings for the German engineers for applications, and they are building and designing the application guide for the next group. So we have application 2 in this example, which means we have domestic hot water on the boiler side of the low loss header. we have zone valves and one system pump. So over here we see we're using a multi-zone control to control all the zone valves and one input from the multi-zone control to zone input 1. So it's a zone circuit. The system pump we control. So we're going to control this pump. So we're going to connect it to the boiler on zone circuit 1. So whenever this thermostat's closed, that pump's going to start. We also have a domestic recirc pump, which we see here. The domestic heating pump is built into the boiler. So because we told it that it's on the primary side, it moves the diverter valve from heating to domestic on the domestic call, right? So what do I pick in my programming? I pick a tank with one sensor. I pick DHW upstream of the low loss header. And I pick a thermostat input. So it's a zone circuit. I pick a zone circuit and 1 in this case. And I can pick either continuous operation or outdoor reset. And I'm going to pick outdoor reset. So I have to have an outdoor sensor. If I pick outdoor reset, it's going to say, where's my sensor? If you don't have it, it's going to give you a fault. If it is there, you're going to see the sensor. It's going to go to weather compensation mode, and it's going to say, what's your heating curve? And we talked about that a little bit earlier in the video. We're going to say heating zone 2, 3, and 4. We're not, or 2 and 3 is a zone circuit. 2 and 3 and 4 we're not doing. And we have no function on the 96 plug. And we don't have any heating circuits. So this is how I just walked through the menu. That's for this piping location, this piping application with this electrical hardware. These are the things I've chosen. Let's look at a different one. Now it's a little different here now because we have one heating zone, heating circuit with a mixing valve, Viessmann mixing valve. We have one zone circuit with a thermostat, right? So we have the mixing valve module, which has our pump and our mixing valve and our temperature sensor and an option for a Vitotrol. So again, I pick one tank, but look where the tank's connected. It's on the downstream side of the lowest header. It's not on the boiler anymore. We put it on this side. Maybe it was already there and we just replaced the boiler. So we didn't want to repipe all this. It was already there. So we pick a tank with a circulation pump and we pick it downstream of the low loss header. And we say we have one mix circuit. And we're going to say we have one zone circuit. And we're going to say we want weather compensation. And we're going to say we don't have any of the other circuits. Now, remember, we had heating circuit 1 in the old control we always used to have. We don't have to do that. We just told it we didn't have it. So now it's looking for only, if you look at the drawing, oops, it's looking for zone circuit 1. Where is that? Zone circuit 1. And it's looking for heating circuit 2. So we just showed you a snapshot of what the control does. But this is a drawing which shows you all of the functionality that this single boiler can do with the right accessories. So let's look at this. And I'm going to thank Scott for doing all these drawings. He did all these drawings. There's a couple more after this that shows you some flexibility. But this is a single boiler now. And the control logic inside is capable of doing heating circuit 1, which in this case is an air handler with a built-in pump. Heating circuit 2, which is a set of panel rads using a Viessmann mixing valve and a pump that we control. Heating circuit 3, which is a lower temperature loop with a heat mixing valve. Now, all three of these and 4 can all be different heating curves. And the boiler will run to the highest temperature and the mixing valves will mix the loops down to a lower temperature to satisfy that particular zone. And this also now has zone circuit 1, which is a higher temperature loop. You have 2 zone valves in this case, maybe through a multi-zone control like we saw in a couple of applications ago. Maybe they're wired directly through end switches. And we control this pump through zone pump 1. Zone circuit 2, again, lower temperature, lower heating curve. But what if one of these is running higher temperature? We put the thermostatic mixing valve just to give it a safety limit. This would have to be set at the design day, but we control the pump. And zone circuit 3. But that's not all we can do because we still have, remember, we still have that external 96 plug. which we can program as an external set point, which makes it zone circuit 4. We have the 0 to 10 modulation, or the 0 to 10 set point. We'd probably use set point in this case to say that we're going to, the snow melt control is going to send me a signal of 0 to 10 volts of the set point it wants. And all of this can be done with the boiler. And the only thing on this drawing, including recirc pump over here, the only thing on this drawing I can't control are these 3 pumps. Everything else, the Viessmann boiler and the accessory modules can control. What if we mix this up a little bit? There's the same application, same hardware, but connected differently. And the reason why we're going to connect it differently is so that we can get some different functionality. Heating circuit 1 is now the panel rads. Heating circuit 2, heating circuit 3, heating circuit 4 really haven't changed. Zone circuit 1 hasn't changed, but zone circuit 2 is now an air handler that didn't have an internal pump. So we had to provide a pump for that. So this pump here can be controlled by the boiler because it doesn't have an internal pump. We still have zone circuit 3, and we still have the snow melt or the pool, which is zone 4 because we programmed as a heat demand. And we still have the 0 to 10. And we still have those 3 pumps we don't control. But let's look at one different way to do it. What if this air handler does have a pump in it and we want to do some other flexibility? So let's look at this way. Now, this piping is pretty much the same as the last one, except the air handler includes a pump. So heating circuit 1 is still the panel rads. Heating circuit 2, 3, and 4 are mixed loops. Zone circuit 1 is the higher temperature baseboard radiators with a thermostat. But heating circuit or zone circuit 2 is now the pool. We'll set that as a fixed set point at whatever the pool wants. Zone circuit 3 hasn't changed. It's still that other temperature, lower temperature loop with the thermostatic valve. And the air handler now is zone circuit 4 as the external set point. Because it has a built-in pump, I don't have to control a pump. That means that the only 2 pumps I can't control now are these 2 on the snow melt system. This pump now, because it's part of zone circuit 2, I can control. And I move the air handler to zone 4 because it has a built-in pump and I don't have to control it. So you see the flexibility in this controller. You can do all sorts of different things with it. Just think it through a little bit, how you want to wire it, how you want to connect it. So pump speed. How do you set the pump speed? Well, the minimum speed is 50%. You can't change that. So this is the lowest curve it can follow. But when I set a pump speed, I need to know how much flow I need against what head I need. So you need to know that information. So this is the boiler pump. So you say, we have a demand at this particular boiler with this particular delta T, we want 6.2 GPM flowing through the heat exchanger. So I can do 6.2 GPM at that curve, this curve, this curve, this curve, to this curve, and I can set it in between. We just give you some lines. You can set it at 65% and we'd be somewhere in the middle, right? This curve here doesn't work. So we don't want to set the pump at its minimum because it's not going to satisfy the flow. And I'm probably not going to pick this curve because it's so close to the end of the pump curve that it's not the best control. You want to set something in the knee of the curve. So we want to pick one of these. But we have one other parameter we need, and that's the head loss. So the head loss in this case, from my loop, from my boiler to my low loss header, we need 6.2 GPM, and we need to do it at 8 feet of head. That's the resistance I have from the heat exchanger and the piping and the low loss header. So at 8 feet of head, at 6.2 GPM, we're looking at this pump curve. And this is a good choice because it's right in the knee of the curve. So what am I going to do with the boiler? I'm going to set that pump speed at 70%, and it will follow this flow rate right here. It'll do 6.2 GPM against 8 feet of head. And that's how I set any pump. So fault messages, we got fault messages coming up differently now than they used to because of we've gone to the decimal inputs. But other than that, it's very much the same. You have this little triangle shows up if you have active faults. If you had a fault on the boiler and nobody had looked at it yet, the whole screen would be orange and it would say, hey, I got a fault, right? But you're going to acknowledge that fault and it's going to put it into this list. If there's a triangle here, this boiler has active faults. So how do you get to them? You push the triangle and you'll get a list of all of the active faults, and it'll tell you what device the fault is in. And this is the BCU is the boiler control unit, which is where all the sensors come back to. So this says it's a lead break. It tells you what the fault address is, and it tells you what the time date stamp is. So you push the fault triangle and you can reset the faults here or clear them. If you haven't fixed it, it's going to come back. This one over here with the looks like a sound waves with a line through it. This is where I can turn off. If I had hooked up to something to that 66 plug and called it a fault, then this would turn off that relay so that the alarm would stop. Once I'm in this, if I hit the button, you hit the line here, it's going to tell me, hey, I got a fault. Do you want to unlock it? So this might be a lockout fault. If it's a temperature lead break on the boiler water temperature, yeah, it's gonna give you a lockout, right? So you can unlock it and then click the check mark and it will clear it off the list and the boiler will restart. Gotta turn that. What's my wife trying to call me? I thought I put it on mute. She must be off work early. Anyways.
Tell her to step on it and get home.
Yes, that's right. She says, I'm on my way home, honey. You got dinner going? Okay. So if you haven't cleared the fault, it's going to come back, right? If you haven't fixed the problem, it's going to come back. So the check mark for the unlock and then the check mark on the screen, it will reset the fault. It will go off the screen. And if it's a lockout fault, the control will then restart the boiler. It will do a diagnostic first, so you'll hear the fan running, and you'll hear a few the few things going on in the boiler, some clicking, and then it'll shut down for 2 or 3 seconds before it starts up again. But that's normal. It's doing a diagnostic. There's also fault history. So under fault history, you can go to faults or status. There's 2 groups. And the last 10 most recent faults, whether they've been fixed or not, will be in the history. If you go to 11, then it's going to dump the oldest one. Again, you might have the same fault over and over again, like it has on this list here. Same fault address. And we have time and date stamp when it happened. So this is a way you can troubleshoot faults that happen every day at 4 o'clock in the afternoon. We had on our old boiler, we had that a funny little story about that the homeowner kept calling the contractor and say, every day at 4 o'clock, my boiler locks out. And I can't find what's going on. Well, what's the fault code? I don't know. I just keep resetting it. So the contractor said, okay, I'm going to come around at 4 o'clock. And what he found out was that when little Billy got home from school, he pushed the reset button a whole bunch of times so the red light came on. Because pushing the reset button a whole bunch of times was a fault saying the switch was bad, right? So he just kept hitting the reset button until the red light came on. So scroll through, reset. You can also clear the fault list and empty it. Let's see where we got here. Now let's look at some of the lists. We have now groups of service messages, status messages, warning messages, information, and additional faults. So we have here service messages, P, status messages, S, information messages, I, and fault or alarm warning messages with A. So you're going to see the number with that number in front of it. And you can see what they are. Sometimes they're just information. Like information that says, external blocking device is active. External demand is active. Well, this is what's happening, right? When we get to the faults, you'll have a list of faults. And again, this is F with a decimal number, not a hexadecimal number. And you'll see how it works here. So in this case, F7, F is a prefix. I know it's a fault. And 7 is the address for that fault. When that happens, the boiler will not make DHW. Why? Because there was a lead break in the sensor. It's on open circuit. Now, remember we talked about you can do aquastat or temperature sensor. If you said aquastat or you hooked up an aquastat and you didn't tell it that, every time the aquastat opens, you're going to get this fault. Every time it closes, you're going to get the opposite fault. And then the last column is what are some of the more common things you need to do to fix the problem? Maybe not everything on the list, but logical troubleshooting. You start with easy stuff and work to the harder stuff. Let's put the easy stuff on the list. If you get faults on a circuit board, whether it's an internal circuit board or whether it's an external circuit board, they will tell you what device it was. So you're going to get on an S1 module, you're going to get a fault at participant 0. An EM1, M1 or P1 is going to be a fault between 1 and 15, depending on the addressing of it. If it's an Ea1 module, you're going to get faults in here. Now, we won't see a lot of these faults because we don't use that many Ea1 modules. We'll only use up to 3. So it'll be one of the 3 lower numbers probably. If you have a Vitotrol that's gone giving you a fault, when you program the Vitotrol, you told it what circuit it was on, but the fault comes up as a participant. So you'd have to look in the manual and say, well, if I got fault 49, that's because it's on heating circuit 2, right? It's that Vitotrol. There are other external devices. We talked about using that little dip switch and leaving it off at the beginning. If I'm going to use a single boiler on a BMS system and I need the gateway, I need to turn that switch on. And the gateway has its own participant number then on the CAN bus. So we can have CAN bus faults, internal and external. Every circuit board has a CAN bus address, and every external device like a gateway or an external boiler has a CAN bus address. There's 2 different CAN buses. And if you're familiar with our existing control, we use LAN for a lot of that. We moved away from LAN to CAN bus because it is the more secured method. The CAN bus has a very high security level. And if you guys don't know anything about CAN bus and you drive a car newer than 1989, it has CAN bus on it. It was originally developed for the automotive industry so that one company can make sensors and devices for multiple manufacturers and be able to network them on everybody's car, but still have the security level of the car to protect that particular manufacturer's devices. So the security level is very high on it. So heat management unit, BCU, the TCU, which is the Wi-Fi card, HMI, which is the interface device, the fan. If it's a cascade, these are externals. If it's a gateway, these are external. All these ones here are internal CAN bus, but you're still going to get that same participant number. So you can see that lead break at participant 50, you'll know that that's on the BCU unit. So if you check the sensor and you said, well, the sensor's good, but what about the wiring harness? Well, I know what wiring harness it's going to now because it's going to the BCU. So now we've got the boiler running. And we want to check to make sure that it's running correctly. We want to check gas pressure. We want to check static pressure, which means we have to shut off the gas valve and hook up our manometer to it. This little valve here has a needle valve inside. You back it off about 3/4 of a turn, and you hook up to the your manometer to it. The reason why you want to shut the gas valve off is because this is upstream of the gas valve shut off, the solenoid valve. You put your meter on there. You open the gas valve. And you should have a static pressure between 4 and 14 for gas and 10 to 14 for propane. If you don't have that, then you're going to have, if you have more than 14, you better call the gas utility to turn the regulator back down. Or if you have less than that, you got to figure out why. And then you're going to start the boiler up and you're going to do an active pressure test. A dynamic pressure test is done at the boiler in high fire. And if you have other appliances on that same gas pipe, it's probably a good idea maybe to run those at the same time. That way you'll troubleshoot any size problems or restrictions or regulators issues in the unit. So again, when it's running in high fire, we still need to be between 4 and 14 and 10 to 14. Then you're going to switch the system off. You're going to shut the gas valve off, and you're going to pull your meter off of it. We also want to do a combustion check. And a combustion check measures for CO, carbon monoxide, CO2, carbon dioxide, and O2. And your combustion analyzer is going to give you this number. Some of them will do NOx as well, draft, and all that kind of stuff. But for O2 is a number and CO2 is a number we're looking for. These are actually reciprocals. So your analyzer probably only is measuring O2. It's probably not measuring CO2. It's doing the math. So you needed to pick the right fuel when you calibrated it. But in this case here, we see an O2 range and a CO2 range. And in propane, we see the same option. You'll see how the same O2 range is the same in both fuels, but the CO2 number is different. That's because LPG has more carbon in it. Its carbon dioxide level is higher. And that's the difference. When I use my combustion analyzer, I look at O2 numbers. I usually don't look at the CO2 numbers because they're reciprocal based on the fuel. So where do I do that? I take this little cap marked in red here, pink here, and I put my analyzer in there. We want to have your end of your probe somewhere in the middle of this chimney port here. And you're doing combustion analysis. You should have a CO level less than 400 parts per million. In most cases, it'll be down in the single digits. But here's something we don't want to do. You do not want to put your analyzer in there and then start the boiler, especially if you've had the power off to the boiler, because Lambda Pro is a self-calibrating combustion management system. And during its calibration period, it wants to drive the fuel air mixture to stoichiometric or Lambda 1. And when we get down close to that range, we're going to see high CO levels or higher CO levels. And sometimes your analyzer is going to crash and you're going to spend 20 minutes purging it. So this is what you want to do. You want to run the boiler till it's run for 5 or 10 minutes and then throw your analyzer in there. Make sure you have a load on it. And then you can do the combustion analysis. So we want to do it two different ways. We can do it if all we want to do is high fire. We can do that through the emissions test, and we would have done that probably is the easiest way to do my gas pressure test because it's at high fire, and we'll do the emissions test. But if I want to operate the boiler for both high and low, then it's best to go into the relay test or the actuator test, and we can set minimum, maximum in the actuator test. So again, in the actuator test, I have what I want the heating output to be, minimum or maximum. One other test we can do if we're using coaxial venting. So we're using a coaxial pipe and pipe vent. Once you've put it all together, you really can't tell if any of the inside seals are put together properly. So if you put your analyzer in the other port, next to the combustion test port is a port that measures the fresh air input. If it's CO2 levels are below 0.2 and the O2 levels are above 20.6, you're good. If those numbers are not within those ranges, then you have to start looking for why. Now, it might be something simple as where the combustion and the fresh air exhaust are on the side of the building. There's crosswinds or there's an alcove that it's sitting under. I've seen people terminate vents under porches, all sorts of goofy stuff. And this will give you that cross contamination as well. Last test we want to look at is the high limit safety test. Now, again, we're using dual redundant thermistors here, not mechanical limits on these boilers anymore. So there really isn't a reason for you to have to do this test because the boiler's doing the safety check in real time. But if you have an inspector that wants to see it or you want to actually witness it, you can go to the test mode in service menu, and it will run the boiler to give you up to the limit test. So you can see it tells you what the limit is and what the actual temperature is. This is a non-programmed boiler, so that's why it shows 0. And the last thing is the home screen and the light guide. The light guide, if you have the control at the top of the boiler, the light guide's on the bottom. If you have the control at the bottom of the boiler, the light guide's at the top. And you can switch that. And Scott talked about that last time. If everything's running normally, the light guide comes on and stays on. If the boiler's in a setback mode, like a sleep mode, the light guide will pulse like it's breathing. If you're programming, every time you push a button, the light guide will go blip to show you that it acknowledged that it saw your button. These are all soft buttons, right? So it's a good way to have feedback. And if there's an alarm, it flashes fast. It flashes on and off, not completely on and off. It kind of pulsates really fast, and you see the light flashing. You can turn this off. There's a setting in the control to turn the light guide off. So some homeowner says, that's just annoying. I don't like that thing. It scares my kids. You can turn it off, right? But if you turn it off, it doesn't mean that you're not going to get faults, because remember, the whole screen turns into a big fault display if you have an active fault. Just quickly, a review of the apps. Vitoguide Mobile is the app you're going to use to commission the boiler if you're going to use the mobile app. There's also a Vitoguide remote that will be available so you can access the boiler remotely. Nice thing about Vitoguide Mobile and Vitoguide Remote is they can both access the boiler through the Wi-Fi at the same time. And that means that if you're a technician on the job site and you know lots about gas piping and lots about plumbing and you've got everything dialed in, but you're not that familiar with Viessmann controls or anybody's controls, but you got a guy at the shop that knows how to program the Viessmann boiler and how to troubleshoot the controls, he can get onto Vitoguide Remote and you can be on Vitoguide Mobile and say, hey, what should I do here? The other app is VCare. This is the homeowner's app. And again, they have a choice of using us or not. And they put it on their phone. They connect the boiler to their Wi-Fi if you didn't do it for them. And now they can access their boiler from anywhere in the world. In the VCare app, you can have 2 heating systems at 2 different addresses on the same account. So you can have a cottage and a home with 2 boilers in it, 2 separate heating loops in it if you wanted to, and all access it from the VCare app. The last one is the vPlan. This is a development software. The idea is that the salesman that shows up talking to the homeowner, he starts putting in data about the existing system, what the homeowner wants, that kind of stuff. And then that goes into a project in the cloud. Then the guy at the shop who's doing the programming or the designing, he can say, okay, well, they've asked for this and this, and they have gas or they have whatever. And they can program, design the piping layouts and the wiring layouts like we showed you before. And they can actually create a commissioning file if they want to. The contractor on the job site, he can upload that commissioning file if it's suitable and download it to the boiler. So right from the salesman right to the guy who's starting up the boiler, vPlan gives everybody access. Now, if you want, you need more information, you need help from the wholesaler, you need help from the Viessmann sales rep or the Viessmann tech support, they all can be involved in this project, right? You just invite them to the project. So that's the software. Now, vPlan, like I said, is brand new. It's in its final development stage, and we want you guys to help with that if you want. Under the vPlan, we are starting what we call an early adopters program. You have to have taken the training we've done online for the installation, application, commissioning, and the introduction. But you can go to this webpage up here and you can register. They will check your email to see if you've taken all that training, and you can be part of the early adopters, which gives you input into the final version of this so that you can make tweaks and adjustments. And that's all I got. And I think Scott just put that link up on the chat. So if you guys want that, it's there. Any questions, Scott?
No, you saved the best for last. That was an excellent,
excellent
go over, man. That was a good deep dive into some stuff there. And I think
just about right on time too. So.
I think we're clear, dude.
All right. Thanks for coming, guys, and enjoy the new boilers when you get them.
Absolutely. Take care.
Bye.